Hello, and hello, and welcome to our From Bottlenecks to Breakthroughs webinar hosted by MicroStrategies with our partners here, IBM, NVIDIA, and the Albert Einstein School of Medicine. My name is Satiris Sergiu. I'm a VP here at MicroStrategies, so I'm excited about today's topic around high-performance computing and AI-ready infrastructure. This session is being recorded, and we will make it available to all the attendees. And in addition, if you have any questions, please use the chat and we will ask the questions at the end. The agenda for the next 45 minutes or so is I will introduce our speakers and then turn it over to them to define an AI factory, followed by a review of the collaboration between IBM and NVIDIA, then a deeper dive into AI-optimized storage, and close it out with a real-world discussion with one of our clients, the Albert Einstein School of Medicine, who has fully embraced high-performance computing and AI. So our speakers today Doug O'Flaherty, a Global Business Development Leader from NVIDIA, Matthew Kloss, Senior Solutions Architect from IBM, Shailesh Shenoy, Assistant Dean for Einstein Information Technology from the Albert Einstein College of Medicine. And these three individuals will go into deeper discussions as we go through. But before I turn it over to Doug to kick us off, we at MicroStrategies have been in business for over 43 years, helping organizations modernize their environments and pivot with technology changes. One constant throughout all the changes is the data. Data continues to grow and is coming in a variety of formats. Talking to many of our clients and partners, they're all struggling to try to connect the pieces and turn that data into something more valuable for their organizations. Plus, it's getting harder and more time consuming. The use of AI is becoming a requirement to help organizations, but our current systems and technologies just aren't able to achieve those goals. With increasing costs and scalability limitations, we need to look at new processes and infrastructure that can connect the fragmented data and help expedite the model training. With that said, let's get the discussion underway, and I hope we are able to provide you with some insight into high-performance computing and AI-ready infrastructure. Again, just a reminder, the session will be recorded. If you have any questions, please put them into the chat, and if there are any that we need to ask at the end of the session, we will do that. But with no further ado, let's turn it over to Doug and start the conversation. Doug?
Thanks, Satiris. You alluded to this early on, that AI is everywhere. And we're seeing this increasing need for scaling and taking a lot of roles from HPC as well on how to do it. But we at NVIDIA think of this as three very important scaling laws that are driving the demand for additional compute. One of them is, as you said, models. It's one we're most familiar with the addition of more training models, sort of our pre-training phase. These models are now, gosh, a trillion parameter model at this point in time, which is a very complex, tightly coupled piece of training that goes with it. As we think about moving forward, post-training, in order to tune a model specific to a specific environment, a specific space, is another piece that increases our accuracy, but also demands compute. How do we take the feedback from a very specific domain or from a very specific set of questions and make the model more accurate? I think Matt's going to have a cool sort of way to think about how post-training really does help you. And then the part that we're really seeing is the new long-thinking inference scaling that is happening. The newest models, and some of this was predicated with the DeepSeek moment, which is now, almost about a year old, where we use a lot of tokens, a lot of intelligence for the AI model to plan, to think, and to continue in a better, more accurate fashion and be more interactive. So, that example that we often use about a model that just answers the question versus the model who comes up with a plan in order to solve a problem. This is the kind of long thinking inference that we're seeing. There's also another component to all of this, which is context. As we take and look at the data that we use for pre-training, it all has to be taken care of. We have the post-training, which will be very specific to that use case. And then in the long-thinking inference scaling, we're bringing in the context of the particular question and the individual. So as we look into the next generation of what's happening with inference, data is becoming more important. And as we go to the next slide, one of the ways that NVIDIA thinks about this is the AI factory allows us to build against that scaling model. we have an opinionated reference architecture which helps guide our end customers, our joint customers, towards what is best practice. How do we tightly couple an environment so that all your GPUs are being very well used? How do we make that possible for you to be able to deploy pre-training, post-training, and inference into the same AI factory to create a data flywheel, as you will, of increasing accuracy and increasing model usefulness? There's another thing that's a brand new class of sort of important AI, which is the AI data platform. This is what couples your current data into a RAG application or contextual search so that you can constantly update it as you go forward. This idea of a new class of AI platform is very important, and I think is going to become one of the ways we heighten both accuracy and relevance to a very specific time and place. It's kind of how we add timeliness to it. And the third thing I want to touch on is NVIDIA invests a lot in our cloud partners of all sorts. That includes people like IBM as well, where we want to have reference architectures that allows a multi-tenant, multi-dimensional way of being able to serve. And for today's discussion, I think taking a look within the context of how an AI factory and an AI data platform work within our NVIDIA cloud partner reference architectures is a good model for enterprise clients and MicroStrategy's clients to think about. You may choose to go down a path with a superpod, which is a more prescriptive, perhaps less multi-tenant. You may choose to go down some other kind of AI factory, but I'll use this as kind of a background to think about how data and compute work together. So if we really think of what the job of an AI factory is, the next slide here, it is about taking data in and creating intelligence on the other side. Now, tokens are the currency of generative AI, of any generative AI. We take and chunk up certain amounts of information into token-like environments, and then we predict what the next token would be. So in a reasoning model, something like a DeepSeek or a Llama Nematron, we see that the tokens go back and forth literally to the points of tens of thousands of tokens as the models interrogate the data in order to come up with something intelligent. But this is where it all starts. Data goes into an AI factory and intelligence comes out. When I talk about that NCP infrastructure, it's that wrapper of how we think it should be built best. So let's drill down a little bit on how that is. These AI workloads, as I alluded to earlier, can be broken down to training, fine-tuning, inference, and this place for embedding and search where the AI data platform lands. Let's make it about storage and take a look at how these line up against a typical storage environment. If we look across the top of the next slide here, we'll see that each of these stages has places where it deliberately and continuously interacts with storage. Now, going sort of from left to right, you talk a little bit about how you've got to take this internal data and you've got to curate it, and you've got multiple data sources. The ability to ingest data into your data lake or into your AI factory is critical. You're going to take and clean some of this data. One of the things that I think Albert Einstein Medical College has got such a great, as an example, is because they deal with multiple classes of highly sensitive data. And how do you properly prepare that so that you can use it for your AI model or for tuning? And then we get into some of the very, very high performance data requirements when we're actually training. And the ability to read that data quickly so that you can keep your GPUs moving on the current job or the next job. Plus another part, which is these jobs can be very long running, kind of traditional HPC. It's part of the reason we focus on high performance storage here. But every time you have to write a checkpoint or take a look and articulate what the stopping point or where the reconstruction point is on a job, you need to write that state down. There's actually a great example from IBM recently published by IBM Research on their ML perf storage benchmarks and how fast they are able to write to IBM storage scale with Blue Vela while doing some of the training on the IBM Granite models. And they're literally talking about writing terabytes of data in a hurry from the GPU and servers down into the traditional storage. And then the last bottleneck that we look at here in terms of how this works is when data is responsible for managing inference. What is the context that comes here? And this is an emerging category, but very, very important, especially as we look at these long-running thinking and contextually aware types of inference, where the storage keeps track of whether or not I logged in or Matt logged in and what happened in the last query. And because machines run much, much faster than we do, that minute that you take to read what the answer was from your AI assistant and decide what to do with it next is actually a chance for the computers to swap out your context, run somebody else's, and then swap your context back in when you're ready to move forward. And so that low latency, highly distributed ability to scale inference, and that is for long thinking, storage becomes critical. Now, in our NCP architecture, as we start looking at the next slide here, our NCP architecture is very specific around what our standard performance workload needs to be to cover that entire spectrum of use cases. And some of the assumptions that we do make, one of them is like multiple concurrent tenants. Not all the jobs are going to be doing the same thing. In an AI factory, there will be some training, there will be some tuning, and there will be some inference. And they may be for different people, different workloads. So we test pretty heavily to see how concurrency and multiple tenants can work there. We test for that super fast checkpoint writing because we know that that's always going to be a part of it. And these low latency inference operations because that's how we get the value out of AI. There's some other parts that we are really think are important, but are a little less prescriptive perhaps that you might not think about. Quality of service for IO settings. Can we guarantee how much information comes back and forth? Do we have enough bandwidth? It's not unusual for a GPU to eat up a gigabyte per second of throughput. And then the number of cases, the size of LLMs, each individual use case is slightly different. So there are some, I don't know, some knobs, dials, and tunings here to trade off in terms of, do you need to go all the way to the top end, or can you work with something that's a little bit differently in size? And a partner like MicroStrategy working with IBM and NVIDIA can help you right size that storage performance. But what we did do, because it's very important to NVIDIA, that anyone who chooses to use and run a GPU, especially with NVIDIA software, in one of our environments gets the most value out of it. So we put together a set of test cases to understand and to qualify and to certify that. So let's go to the next slide. And IBM has submitted certification on multiple platforms. One of the things I'm happy to say as somebody who works every single day with IBM, the IBM storage team has been responsive, leading edge, and on top of these understandings of how do we build different scales for different environments. For example, they have one of the largest installations of Grace Hopper out there already with an installation in Ulix. So they have ability to not only work with our standard x86 environments, but they also work with our ARM environments, which are highly power efficient. And very recently got their GB200 and GB300, which is our Grace Blackwell, most leading edge, large scale systems certification for our NCPRA. Things that made it important were where they met the qualifications for high performance, linear scalability, high reliability, including in the architecture of both the network and the way they manage it, the losslessness as you move through to be able to upgrade for data, because this is a 24/7, 365 environment. Their multi-tenancy support, of which they have 2 or 3 different models, which work depending on whether or not you want to be an enterprise with a certain type of shared multi-tenancy, or even multi-tenancy that can be divided up between competing businesses. The quality of service controls continue to evolve and have demonstrated that their throughput and guarantee performance meet our requirements with dynamic controls, because these are dynamic environments. The dynamic ability to grow and move different parts of that AI factory are one of the things that Storage Scale 6000 certified against, and they have met all of our requirements across the board. It has been a true pleasure to be working with IBM. Now, I want to sort of summarize this up for you all and then turn it over to Matt. We can look at the next slide and talk a little bit about what have we really hit on? The AI factory, as exampled by these NCP architectures or a superpod architecture, are increasing their token input and output with inference. All 3 scaling means that you're really actually driving more compute as you have usage. It's not just it takes a lot of compute for training. It now takes a fair amount of compute for training, for prompt tuning, and for inference. You want to make sure that you scale your storage systems required. And that's one of the reasons that we certify and test multiple high-performance file systems. And security and multi-tenancy are key features as we look forward into how the environments are going to grow. Now, IBM Storage Scale with 6000 has met all these certifications for NCP, and it's really great to be able to be continuing our collaboration with IBM, not just on AI factories, but on something that Matt's also going to talk a little bit about here, which is the AI data platform and the IBM content-aware storage. So Matt, I hope teed you up with some interesting things. We're all available for questions. Put them in the Q&A is our preferred, but we're all monitoring. We're all here, and any question is a great question. So Matt, over to you.
Awesome. Thanks, Doug. As Doug pretty much, not alluded to, but, laid out, data is truly the fuel for an effective AI strategy. It's really the underpinning, and there's different phases of the AI life cycle, right? From training and data, the data collection phase of AI, to the model training phase, to the fine tuning phase, to the inference phase, and if you're going to use an off-the-shelf large language model or AI model, it's really only been trained on 1% or 1% of the data. And it's been all scraped from the internet or from public data sources. But your enterprise's data only represents about 1% of that. If you ask a large language model, or you ask ChatGPT, or you ask some source about information specific to your enterprise or about HR records, it will have no idea. So it's really important that we take your data and bring it into AI for both contextualization and information. And on the next slide, we'll talk a little bit about some of the customer challenges we see, right? We see escalating infrastructure costs, right? Training of models is very expensive, right? You see these AI data factories and these large scale training environments and clusters, they can be very expensive. So it's important to keep those GPUs fed. It's important to keep them running optimally, but also to understand that there's different tiers of storage for this as well, right? Not everything needs to be on the most expensive tier, and that's not, no enterprise puts everything on the highest performance of storage. There's different storage areas, though. It's important to manage that. And then understand that AI is also distributed, right? It could be running in the cloud, it can be running on-prem, it can be running in a hybrid methodology. So having a data platform, a data plane that is accessible across both on-prem, cloud sources, different environments, whether they're containerized, whether they're running on bare metal, whether they're running in cloud environments. All of that data needs to be delivered transparently to the AI environments. And also, it's really fundamental that we see that AI is a critical business asset, right? Most notably is explainability and governance, right? You need to be able to explain what is in your result, right? If you ask ChatGPT, or you ask, I use ChatGPT as a reference, but you ask any large language model and a question, can you explain, and can that model explain where it got that answer from, for both governance reasons as well as for explainability. We always see the example of chatbots presenting the wrong answer or incorrect results. So it's important that we add this layer of governance and explainability to models. And on the next slide, we can really go through really what is training and inference, right? So training is the process of teaching an AI model. You're taking data sets that are from either your enterprise, your collected data sets from within your enterprise, or from data sets that you've procured from the internet or from public sources, and are putting them into a model. You're spending a lot of computational effort to train a model. And then the next, if you tab forward, you'll see the inference piece of it, right? And this is really taking a model and feeding data into it to generate a result, predictions, conclusions. All of that is really the piece of inference. And when you really trim it down on the next slide, it comes down to two pieces, right? Training costs you money, right? You're spending a lot of time, effort on compute infrastructure. You're training your own custom model from the ground up, whether that model is specific or whether it's more general, right? We think about the large players out there, Llama, Grok, IBM with our Granite models. But a lot of that is very cost inefficient, so to speak. But the inference piece of it is where you hope to make money. You're going to take this model, maybe you're going to fine tune it a bit for your specific business, or implement some unique capabilities such as retrieval-augmented generation, or RAG, which we're going to talk about IBM's solution to this a little bit later on. But fundamentally, you're taking a model and you're hoping to make money with it. That is the goal, right? Or have a business outcome. And on the next slide here, we're going to talk a little bit about some of the training that we've done with IBM's Granite family of models. If you click through this, you'll see a lot of the Granite Granite family of models have been in the news lately, quite a bit, right? There's a lot of great. Oh, I think we lost the slide deck. But nonetheless, the Granite family of models are available on Hugging Face for immediate use if you'd like. I think, Caitlin, if you need to reshare, if not, I can take over quickly.
It's coming right back up.
No good webinar doesn't have a glitch.
In the meantime, IBM spent a lot of time and effort and is in a very unique position, I would say, where we're a very large technology company. We have mainframes, we have storage business, we have cloud business, but we also have a research business. And that research business is in charge of training large-scale large language models. We call them our Granite family of foundation models. I've had the pleasure of working with them and designing the storage solutions behind them. And it's really important to show that the infrastructure matters. So if you actually, you can probably just jump to the next slide here. But the infrastructure does truly matter, right? One more click should get you there.
There we go.
There we go. Perfect. Yeah, the infrastructure really matters, right? This is our Blue Vela AI supercomputer that I've had the pleasure of working with research and building. So the research team spent a lot of time and effort to build this cluster following the NVIDIA reference architecture. That's laid out in the next slide. And can be read about in this research paper. I've linked at the bottom. You'll have access to it later. But we followed the NVIDIA reference architecture because it's a truly scalable architecture. It's designed for high performance computing. And in this case, we actually have 6 different compute pods. We have 6 H100 GPUs in these Dell HGX servers in this case, providing our research team with the incredible performance and scalability that the NVIDIA SuperPod reference architecture represents and presents. And on the next slide, you'll see the storage that's backing that. As Doug's mentioned before, the Scale System 6000 can provide incredible performance, things like multi-tenancy, QoS, and highlighted at the top there is 4 Scale System 6000s, roughly 4 petabytes of storage in this configuration, with an NVR InfiniBand and over 1 terabyte a second of performance there. It's actually closer to 1.2 terabytes per second. We also have tiers 1 and 2 of storage in this cluster, right? We have 3 petabytes of storage, roughly 500 terabytes of NVMe, and roughly 2.5 to 3 petabytes actually of HDD, right? We've got a multi-tiered storage approach here because, again, not everything needs to be on the fastest media in the world, but it needs to be accessible. It needs to be under a single data plane, a single global namespace. Data is dynamically tiered, transparent to the user from the high performance tier down to the slower spinning media, more cost-effective tier, and vice versa. As needed, it'll be brought back up. So we're implementing a 3-tiered approach within that training cluster, and we're still getting incredible results. So on the next slide, we ran through some of the MLPerf storage benchmarks. As Doug alluded and mentioned before, this benchmark is designed to not just simulate large-scale sequential bandwidth like IORs or some of the IO500 tests, but it's designed to emulate very specifically the storage requirements for training. And in this case, these are specifically the checkpointing of large language models, right? That's really the right phase of a training sequence. So in the bottom right there, you can see the checkpoint size in gigabytes for each of these different llama models, which are used as part of the checkpoint or part of the benchmark. So the checkpoint size on a 1T model, right? 14 bytes per parameter times 1 trillion ends up being roughly 15 terabytes of data. During that time, GPUs are sitting idle while they're writing that checkpoint back to storage. So if you have a very fast, very scalable storage solution, that is able to take that data out of the GPU, get it down to the storage as fast as possible, in this case, roughly 37 seconds to save it. And then when needed, read back in about 23 seconds. You have an incredibly scalable, incredibly performant solution for training large language models. And you're going to say, Matt, well, on the last slide, you said that cluster was capable of over a terabyte a second of performance. Why are your results only 656 gigabytes? Where's the remaining 300 plus? And that's because during our benchmarking tests, other workloads were actively running, right? This multi-tenant, this QoS that we actually implemented allows us to, allowed IBM researchers to continue using and training large language models, specifically the Granite 4 family of model on this cluster. We took a handful of nodes to run the benchmark using shared storage infrastructure and still achieved very, very good results here simultaneously. So it really, showcases the ability in the most real world manner that we can achieve with scale, very high performance in a shared infrastructure environment. On the next slide, now we're going to switch gears a little bit from training to some of the trends we're seeing in storage when it comes, from Gartner, right? So Gartner is talking about retrieval-augmented generation, right? Bringing storage and bringing AI into the data platform and really making your storage and your unstructured data more queryable. And IBM is at the forefront of this and working with our partners such as Albert Einstein to implement our CAS solution, our content-aware storage. And on the next slide, we'll talk about the 1% problem, right? I kind of alluded to this on my first slide, talking about how 1% of enterprise data is available in public large language models. But less than 1% of enterprise data, is there. So it's mostly unrelated to your enterprise. And when you're going to begin training data or fine-tuning large language models, you're going to end up copying data between different locations. You're going to end up having to take a pause, right? Maybe it takes a week to train that and fine-tune that model. Well, now that model is already a week out of date. You're not keeping up to date with the latest changes. And maybe a week is even generous. It could be a month. Maybe once a month you're running a fine-tuning workload. So that model is potentially out of date. This is the 1% problem, right? 1% of enterprise data is in the open source models, but 99% of your data is specific to your enterprise. So on the next slide, this is really IBM's content-aware storage. We're moving data to the AI. From moving data to the AI to moving AI to the data. We're bringing data as close as possible to the AI, and that's by embedding and leveraging AI technology inside the storage to make that data, content aware, right? Leveraging our content awareness to accelerate inferencing efficiency. So this is all about inference workloads. The first piece was talking about IBM Research's, ability to help you design and build large training clusters. But now we're talking about ways to take those models and deliver them in a way that makes you money, so to speak, right? Content-aware storage handles all the pieces of embeddings, chunkings, as well as summarization, labels, tagging. All of that is handled under the covers for you in this content-aware storage pipeline. So on the next slide, we'll see the first piece of the pipeline, which is really this. You can play the video up top there if you just scroll up. Scroll up and click on that. It should give you the video just to play it. This is really showing how you can upload a document into a CAS-enabled file set. So in this case, it's IBM's S3 Deep Archive, right? Our tape solution, just a PDF in this case. So a couple PDFs are uploaded into the content-aware storage, and this doesn't have to be just uploading of PDFs. It supports many, many media types and can be used in a number of ways, but for simplicity's sake, uploading data into the content-aware storage. And then on the next phase, next slide, you'll see the documents are uploaded, and the next, you can click through this. The documents are then extracted, right? Because you can't, the formatting doesn't matter to a large language model. From there, the text is chunked into consumable pieces. It's then vectorized, basically made a tokenized version of that data, and then finally it's stored in a vector database, made accessible to RAG applications, right? We call this our content-aware storage. So that PDF that was just uploaded can be queried. So this is really awareness, storage awareness, bringing the AI into the data plane. And this all happens transparent to the user. I've kind of broken down the different phases of RAG, but all of this is transparent to the end user. Data changes that are happening in real time on your storage, and your unstructured data can immediately be represented in a large language model or a chatbot, so to speak. You tie this in with things like agentic AI and MCP, and all of a sudden you have a very powerful solution where the results you're getting back are both explainable, governable. You can ask, you can find out exactly where this entry came from. As you see there, it came from the PDF. It was very explainable and governable by using this approach. So on the next slide, this is really IBM's content-aware storage. It helps you provide flexibility, integrates with our Fusion data services. So you have Scale, our OpenShift data container platform, Fusion, and a highly scalable vector database that sits within Scale, grows with the storage. So as you continue to add data sources, it will grow effectively infinitely. And that can be made accessible through APIs to really any large language model. We're leveraging NVIDIA NIMs and the NVIDIA Nemotron transformer to help with data extraction and moving of those files into a vector database format for use with large language models. And most importantly, at the bottom here, there's external data sources, meaning not all the data needs to be copied into Scale. Maybe you have other data sets on-prem or in the cloud, right? So whether it's on-prem NAS storage you have, whether it's on-prem object storage or cloud object storage, whether it's Scale storage or tape storage, all of that data can be brought into the storage Scale data platform, data plane, and made accessible to this architecture. And again, all of that is handled seamlessly under the covers. I'm laying it out for you a little bit, but that is made accessible to your chatbot and again in near real time. So as a developer, as a researcher, is updating data sets and making changes to files, it's very fast and very real time being updated in the data vector database. And then we're going to show just a little bit of a video. There's actually a longer version of this. But this is going to talk, kind of lay out what content-aware storage is and some of the benefits.
AI assistants have already transformed the business landscape. Now they're evolving into AI agents, automating complex tasks to unlock new efficiencies. But there's a problem. AI models weren't trained on the latest data behind the corporate firewall. The PDFs, presentations, videos, and emails they need to produce accurate, up-to-the-minute answers. Content-aware IBM Storage Scale is a new class of AI infrastructure that integrates enterprise storage with NVIDIA AI data platform for enterprise, and it does so while preserving data access controls and without unnecessary copying or migration of data. This capability is well suited to research applications, which need to ingest many information-rich documents. As newer updated research is added to the repository, IBM Content-Aware Storage automatically updates the vector database to keep the information fresh. IBM's unique method of incremental updates is faster and more efficient than conventional retrieval-augmented generation rebuild. By leveraging the NVIDIA IQ blueprint built with NVIDIA NIM microservices, IBM Content-Aware Storage helps organizations extract hidden value from their existing data. Content-aware storage, a competitive edge in the era of the AI-empowered enterprise.
That's an abridged version, a shorter version of the video. It's a couple minutes long. It has a lot more examples and goes into greater detail of some of the capabilities. But I hope it lays the foundation to what IBM Content-Aware Storage and our RAG implementation is capable of. So we've talked about our the abilities of Scale to support training workloads, but now we're talking about Scale's ability to supplement and implement inference workloads, things like KV cache acceleration as well. As Doug mentioned before, inference is sort of an emerging field, so there's a lot of work being done to improve that, the time to first token, they call it, within Scale. So on the next slide here is really the summary. Is really the summary here of really Scale's ability to unlock business value in unstructured data, right? Content-aware storage can help you gain a cognitive edge, help to accelerate inference, simplify our operations, and it's Scale is fundamentally designed to enable content-aware capabilities and scale with your data set and data growth for unstructured data. So I think I'm going to turn it over now to Shailesh, talk about real-world use cases for Scale in his organization.
Yes, and thank you, Doug and Matt, for that deep dive into the technologies there. And Shailesh, thank you for joining us today. as we explored high-performance computing and AI-ready infrastructure that are transforming research and analytics, especially the way they use innovations like content-aware storage that Matt just mentioned. To start off, could you share a bit about your background and role at Albert Einstein College of Medicine?
The chairs, first of all, I want to say I'm really excited to be here. Thanks for this opportunity to participate. What a great start to this webinar, to talk about the solid foundation of technology. Who would have thought that this is where we would be years ago, right? I mean, this is really amazing, right? To be on the threshold of something so incredibly exciting. And we're doing this all together, of course, and I think this is really, pretty interesting. So my name is Shail Shenoy. I'm at the Albert Einstein College of Medicine, where I'm the Assistant Dean for Information Technology, CIO. The institution is a research-intensive medical school. So in addition to educating students who are earning an MD or a PhD in the biomedical sciences or a combined MD, PhD, we also have about 300 laboratories that are funded by the National Institutes of Health to do biomedical research. And so you can imagine there's quite a bit of demand for being able to leverage technology on the compute side. And as we've been discussing already, what drives this are data, unstructured and structured data, and being able to efficiently provide those data and access those data for compute.
That's great. And again, thank you again for being here and kind of wrapping this all together, because it is an exciting time. But can you tell us about the initial challenges you had and you were facing before instituting high-performance computing and AI-optimized infrastructure for the college?
I think for any institution, one of the initial challenges is having the data accessible and easily accessible, right? Because what happens over time, just organically, is that you have all of these disparate ways of storing data, right? On NAS devices or on some central file service that's per department. But once you start aggregating that institutionally, then you have that real ability to be able to collaborate throughout the institution. And then to be able to collaborate with other institutions, in a way that is cyber secure, right? Because let's remember, the manifestation of our intellectual property is in the format of petabytes and petabytes of data, billions and billions of files, right? And so it's our responsibility to make sure that we're storing all those data in a way that's resilient and protects from, cyber threats that are out there, of course.
Right.
And so this ability to be able to bring this all together and comply with all the rules that are out there. For example, most recently under the Biden-Harris administration, there are new rules under National Security Presidential Memorandum 33 that govern the cybersecurity that we have to apply to the intellectual property that we generate using NIH-funded research. This all has to be taken into consideration. It cannot be done with disparate storage systems that exist throughout the institution. So it takes some time to be able to do all that. And this is a road that we've been down for many years. And I think that that's really step one, Satiris, is making sure that we have all of that together and that there are proper access controls. So, that access control on all those individual pieces of data have to be put in place so that we have confidence that the ACLs reflect like who should have access to the data.
Right. And for the audience, a lot of people that are listening in, they may be looking to embark upon that journey. Is that a tremendous effort or workload? Any guidance to them on how to kick that off? Or
Well, what I would say is the first thing is, building consensus, because this is not like, a simple, it is copy and paste type of scenario, right? It's like,
right.
Everyone has to understand, what does this represent? Why are we doing this? What's the mutual benefit to undertaking this? And I think once that's in place, there also has to be a commitment to make sure that there's good performance, right? Because you have to make sure that any such system is going to be able to meet the diverse needs of a research institution. It doesn't matter if you're just within a department of biochemistry or just within a department of neuroscience. The needs are so diverse in what people need, the size of the data set or the type of computation that's happening or the type of workloads. So everything from high performance computing, which would benefit, of course, from having a parallel file system and the fastest possible transfer of data with the lowest latency, down to people being able to get access to home directories from their desktop or laptop. That's all critical. So for us, one thing that made that work so well was to have a single namespace. So there's a one global namespace for all activity. That way we're not kind of duplicating files in various different silos. Right. And then the other thing that happens, of course, is to as we were talking about earlier on this webinar, is to have a tiered file system, right? So that you can have the best cost efficiency.
Oh yeah, yes. With that said, can you walk us through your current environment that you have at the college?
Yes, so we leverage, I think, one of the strongest platforms for storing data in a resilient fashion. And for that, we use IBM Scale, storage scale, and the hardware that goes with that. And one of the things that allows us to do is to responsibly and in a resilient fashion be able to store all our data. So all our data are in two separate colo data centers on two different power grids. We're in New York, we're in the Bronx, New York, so our data centers are on either side of the Hudson River. And what happens in that scenario is when we write data, we're writing data to both simultaneously, to both data centers simultaneously. So if anything were to happen for any reason to one side, the other side continues operating without any loss at all to our ability to access our data. And then those data are in a hot tier, as you might expect, a warm tier, and in a cold tier, and an archive tier. But it's all in a single namespace, so everyone sees all their files at all times. And I think that's one of the real strengths of the file system, is that ability for all of this to happen seamlessly with a single pane of glass for managing that. And then, of course, all of that gets backed up to a third site, and then there's a disaster recovery at a fourth site. But all of that is, I think really key and fundamental to making sure that, we're able to do this well. So we can manage, for example, high performance computing workloads, AI workloads, with the speed and with the low latency that's necessary to be able to meet those needs, and also meet the types of needs that happen with multi-protocol, right? So we have the native parallel file system with Scale, we have NFS, and we have CIFS or SMB for desktop access for home directories. And I think that, all combined with the POSIX native permissions, make sure that we have that robust ACL for every single file. Right. It's really, I think, what gives us that resilience that we need.
Oh, it's great. That's perfect. Yes. And we heard a lot today about the future-ready infrastructure, agentic AI, and, and you've heard about the IBM and NVIDIA collaboration. Looking ahead, what are you exploring, and can you share any of the early work your team has done with the content-aware storage and AI? That would be great to hear what plans you have.
Yeah, well, I have to tell you, I mean, this is pretty amazing, opportunity that we have as a research institution, right, to be able to leverage the power that this represents. So, for a few years now, I mean, researchers at Einstein have been making their own models, and of course, leveraging models that exist. And that's already proven to be quite successful and efficient in being able to optimize the way that people work. Right. So once again, if we look at the layers, right, I mean, there's a training layer, as we all discussed on this call, on this webinar, and then there's the inference that we get afterwards from there, which is so powerful. And in our case, we're not making money. What we're doing is we're generating new intellectual property, right? We're examining the hypotheses that people have. And so that by itself has been pretty powerful. But then this ability to be able to quickly and easily access data in models is exactly the opportunity that content-aware storage provides us, right? And I think in the beginning, we're looking at relatively mundane tasks, but I think over time, this matures into being able to help scientists do things like literature review more easily, right? Because what we're looking at is not just the published literature that's out in the public, but also what we're looking at is what is the private content that we have, right down to the granular, what's within a laboratory, within a researcher. Because content-aware storage respects the ACL that's on the actual content. And I gotta tell you, that's something that's very, very important, right? Because it's not just about having your institutional data. I mean, for us, I want 0% of our institutional data to be in a publicly available model, right? Yeah. The publicly available model shouldn't even have 1% of our institutional data. It really should have close to nothing. Yeah. Then internally, we have this ability to inject information, but we would not want the information from HR to be accessible to the entire institution. And even within HR, we would only want that to be accessible to within certain groups. The same thing would apply within research, right? This is the intellectual property for the laboratory. It's not necessarily public. So what we need is that ability to respect those boundaries. And that's something that's so powerful with content-aware storage.
Oh, that's great. That's wonderful. Sounds like an exciting time for you going ahead. You've come a long way and continue to grow, which is wonderful. And thankfully, IBM has been with you along the way and continues to be there with you. And obviously, NVIDIA joining as well. Shailesh, again, thank you so much for joining us. I'm going to just allow Matt or Doug to say a few words before we close the session out. Any closing comments on what Shailesh may have mentioned, or from either of you before we close out the webinar?
I'd just like to start by saying, Shailesh, thank you for being a great IBM partner. You participate in a number of events. You, work directly with our researchers, you work directly with us to help, provide feedback from your institute, what you're seeing, what you're doing. And so it's been an honor to work with you, and it's been great to work with you over the years. We're very happy to see you using IBM's products and putting them into real use cases, and your willingness to talk about them, with our community, just like you are on this webinar. It's been a great partnership.
Really appreciate the partnership. I want to just emphasize here just one more time, just quickly, it doesn't matter the vision, doesn't matter, the resources and bringing people. If you don't have the right partnership, you have really nothing. And I think that's one of the great things about what we've been able to do collectively with NVIDIA and with IBM and of course MicroStrategies. It's been really very productive for us.
It is how we learn and progress the business, isn't it, Shailesh? It's been a joy.
Indeed, yes.
Wonderful. Thank you, Doug, Matt, and of course, Shailesh. Thank you so much as well. To all the participants, if there are any questions, I don't see any in the chat there, but if you do have any questions, feel free to reach out to us here at MicroStrategies. We, in conjunction with IBM and NVIDIA, will discuss any questions you may have. And also for any participants that have joined today, we're more than happy to spend have a strategy session with you, regardless of where you are on your journey, whether you're at the beginning, halfway through, or embarking like Shailesh onto the next chapter. We are here to assist, so feel free to contact us. And again, this recording will be available to everyone who joined. And thank you all for joining the webinar. Have a wonderful rest of your day. Thank you.